All right, this is going to be the learning target, chapter 3, learning target number um, 2 video. Um, at this point, we've worked on computing quotients of mixed numbers, fractions, and whole numbers, so we have that down, or at least should. If not, we need to continue practicing with that. But just remember, division is just multiplication by the divisor's reciprocal. So we know that this is going to be the same thing. So 2 is just going to be computing quotients of mixed numbers. So it's the exact same target, only what we're adding is we're adding in real world context. So now we're going to go through and we're going to learn a little bit about which number is being divided, all that kind of stuff. All right, so got to skip down here a little bit. I think we're on page number, did all that, that's all first one. Here we go. It should be on page 9. Page 9, so it should look just like this. Okay? All right, so here we go with the first word problem here. Now, I want everybody to just ignore use a model to solve. We're not using models this year. We decided to not do that, so we're not going to worry about this. But I really want to go through something that I think is important, okay? I'm going to write this, and you guys don't have to write it. Actually, yeah, go ahead and write this. So that says P plus P equals W, and I'll explain what that means in a minute. This is going to say P times P equals W, okay? And then I'm going to write W divided by P equals P, and then W minus P equals P. Okay? Give you a second to write that. All right. Now what that means is the P's in this problem stand for part. Okay, so we can write that if you want. P stands for part. The W in the problem stands for whole. Okay? Now one thing we've got to understand, guys, when we're doing multiplication, or let's say adding, let's start with the basics. Part plus part equals whole. What I mean by that is, let's say I was counting up fruit. You don't have to draw what I'm about to draw. Let's say I have a basket or a bowl. Oh my gosh, that's terrible. Okay, let's say I have a bowl. Okay, let's try that again. Still bad, but better. Okay, so there's my bowl. Let's say that in that bowl there were blueberries. So make them blue there. There's that. And then we'll do orange for oranges, so we'll do some oranges too. Okay. There we go. And there's my oranges. I don't know why the oranges are bigger than the blueberries or smaller than blueberries. I have no idea. Just bear with me for a minute. If I wanted to figure out the whole, that would mean a total of some kind. So we're talking about the total pieces of fruit in this basket. Well, what I would do is I would add the two parts together. So the first part would be representing the blueberries. So as you can see, I have 1, 2, 3, 4, 5 blueberries. Okay. I have 1, 2, 3, 4, 5, 6, 7, 8 oranges. Okay. So because I know two of the parts, I'm going to add those together to get a whole, a total. I have 13 total oranges. Okay. Same with multiplication. Let me do a quick example. Let's say that I have a garden. Okay, here's my garden. Again, you don't have to draw this. I just want you to be listening, trying to understand where I'm coming from here. Let's say that I have this many. That's not a good example. I don't want to do that example, actually. Actually, that does work, I think. It'll work. I'm sorry. Let me bring that back. Sorry. I was thinking about something else that I wanted to do, but okay, obviously it's going to be all glitchy now and keep taking away everything. Okay, so if I bring that back, and then I had my garden, I had 1, 2, 3, 4, 1, 2, 3, 4. These are tomato plants, we'll say. And I have tomato plants. What I can do is if I want to figure out how many total tomato plants I have in this little garden here, sure, I could count them, but I think most of you would see, well, I can do 4 times 3. Well, that gives me 12, which is a total, right? How else could I do that? Well, I could realize that I have 1, 2, 3, 4 in each row, 4 tomato plants. I have 3 rows. That gives me a total. So those are just parts. I had 5 blueberries and 8 oranges. I put the parts together to give me a total. Here, I had 4 in each row. I had 3 rows. I multiply them together to give me a total. Okay, so whenever you're adding or subtracting, You know the parts. You know the parts. You're trying to find some sort of whole, some sort of total amount. Okay? Now let's flip around for division and subtraction. Division and subtraction, we know the whole amounts. We're being given the whole amounts. For instance, let's say that, again, don't draw this, just watch. I have another bowl of fruit. Now I have my blueberries in there. Okay? And I want to know how many oranges I have. So I don't know how many oranges are in there. So if I told you that the total amount of pieces of fruit in this right here was 20 total pieces of fruit, and I know there are 1, 2, 3, 4, 5, 6, 7, 8 blueberries, I'm going to do 20 minus 8 to figure out that, oh, I must have 12 oranges in here. Okay? Again, I'm being given the total. I'm being given the whole. That's how I know I'm using subtraction, is when I'm being given some sort of whole. Well, division is no different. You are given a whole, a total amount. It's always going to be whole divided by part equals part. So the whole, like for this one down here, I could say, okay, I have 12 total pieces of fruit. I know that there are 3 rows in my garden, so how many tomato plants are going to be in each row? That would be a true division problem because I'm giving you the total amount of strawberry or tomato plants. I know there were 3 rows of them, and that gives me the other part. So this part right here can represent 2 things. It can represent the amount of groups. Remember, groups always means division. When you're breaking something into groups, we're talking division. Okay? So it could be the amount of groups or the amount of items in each group. And we'll talk more about that as we go. Okay, so I'm going to get rid of all this now. Actually, no, I'm not, because I don't want to get rid of that top thing there, because I just think that whole divided by part thing is really, really valuable, and you're going to hear it a lot, so you may as well get used to it right now. It's something that I refer to a lot. I'm talking about this up here. Okay? All right. So here, again, don't worry about write a story. Don't worry about any of that. That's not what I'm trying to do. I did not want to get rid of that. Dang it. Shoot. Oh, I brought it back. Good. Okay. So Mariska has 2/3 of a pound of sunflower seeds. That's how much she has. Each day, she feeds the cardinals in her yard 1/6 pound of seeds. For how many days is she going to be able to feed her cardinals? So I think we're doing division of fractions and mixed numbers, so I think everybody knows that we're either doing 2/3 divided by 1/6, or we're doing 1/6 divided by 2/3. Okay? Now this is where it really comes back to whole divided by part equals part. You have to ask yourself, is this the number that's being divided, or is this the number that's being divided? Remember, the dividend, this first number is the dividend, okay? And that dividend is the number that's being divided, being sectioned off, being grouped up, okay? And I hope you're all realizing that if she has a bag of sunflower seeds and she has 2/3 of a pound, that's how much she has. This is what's actually being divided up. It means 1/6 is going to go this day, the next 6 the next day, and so on. Okay? So the number that's being divided, you're going to hear me say this an awful lot. I'm always going to be asking you to look for what is being divided. 1/6 isn't being divided. That isn't the total amount. That isn't the whole. Okay? 2/3 is. So this would not be correct. So now, to do this question, we're just going to have to do that algorithm for division, remember? When we know that division is just multiplication by the divisor's reciprocal, and we do the problem. So now, we'll go ahead and keep the dividend the same. That's not going to change at all. 2/3. Division is going to become multiply, and the reciprocal of 1/6 is 6/1. Okay, so I'm going to rewrite this so we can see it a little bit better. 2/3 times 6/1. Now remember, at this step right here, whenever you're multiplying fractions, you can actually do that cross-simplifying method, remember? So that's where you look diagonally and you ask yourself, for 2 and 1, is there a factor that you could divide out between them? Well, the only factor of 1 is 1. So 1 doesn't help us, so we can't do anything there. So we'll go to 3 and 6. What factor does 3 and 6 share? Well, if you need to go over and do your trees for 3 and your trees for 6 and find the GCF, you can do it that way. Hopefully you realize that they both share a 3, so we're going to divide both those numbers by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. And that's going to give us 4 over 1, which we know equals 4. So it makes sense. If we start with 2/3 pounds of sunflower seeds, and she's using 1/6 per day, remember I said this part right here could be either the amount of groups there is, the days is representing the groups, or it could be the amount of that's used in each group, which in this case it's 1/6 per day. Okay, let's do another one. Okay, I'm going to erase here a little bit. Actually, yeah, let me just erase that. Okay, so now, at summer camp, the duration of a field hockey game is 3/4 of an hour. The camp counselors have set aside 6 hours for field hockey games. How many games can be played? So again, you have to identify what's being divided. Are we dividing the 6 hours, or are we dividing the 3/4 of an hour? What is being divided up here? We're not taking 3/4 of an hour is 45 minutes. We're not dividing that up. Okay? A lot of people would do 3/4 divided by 6 here. That is incorrect. Okay? This isn't the dividend. That's not what's being divided up. What they're trying to divide up is the 6 hours that they have. So we know that we've got to do 6, and then the divisor is going to be how long each game takes. So we're going to go ahead and make that into an improper fraction. That's step number 1. And then step 2 is to then do that algorithm again. So 6 over 1 times 4 over 3. Again, we're faced with this situation where we have 4 and 1 there. That isn't going to help us. 3 and 6 have a factor of 3 they share, so we're going to divide that out. 6 divided by 3 is 2. And then we end up getting 8 over 1, which we know equals 8. What does that mean? That means that they can play 8 games in this 6-hour time period because they're only 3/4 of an hour long. Okay? Let me go down here, do another. Okay, I'm going to have to erase some of this. I don't want to erase that. Well, it's gone. We're all right. We don't need it. Okay? Turner has 6 pounds of pasta. Each time he makes dinner, he uses 3/4 pounds of pasta. How many dinners can he make? Again, we know that it's either going to be 6 divided by 3/4 or it's going to be 3/4 divided by 6. Now, it just so happened that these questions were the exact same, so I'm not going to mess with the problem because we did it up here. But what's being divided? Is this the amount he's starting with, the whole? No, he made this whole amount. This is your whole. This is your part. And since we know we're doing division because we're breaking it into, we're trying to figure out how many dinners he can make, we know that this is going to be 6 divided by 3/4, which the work for that's just right above there. Okay? Let's do the next one here. Okay? Raphael took 4 pumpkin pies to a family gathering. If he divides each pie into 6 equal slices, how many slices can he serve? Okay? Well, you can look at this one and you got to figure out what's being divided. What's being divided here? Okay? Now this one really, what it really is you're doing 4. Here's how a lot of you would solve this. A lot of you would say, well, it's just 4 times 6, which is 24. Because each pie has 6 pieces times 4. How would this be division? Well, I'm glad you asked, because I'm going to explain it now. Okay? You would take 4, because that's the whole. That's obviously what's being divided. He's dividing that up. He's cutting it up into pieces. And then we're going to divide that by 1/6. Right, everybody? Because even though it says 6 equal slices, we're saying how many 1/6 are there going to be in 4. That's something I want to start saying a lot. I should have said it up here, but I'm going to say it now. This one here, whenever you're dividing, you're asking how many groups of 3/4 would go into 6. That's why the number got bigger up there. And you got whatever it was. I don't remember. Okay? So we're saying how many 1/6 groups would go into 4? Well, this is why it's 24. It's so weird to think about division and then getting an answer that's bigger. But let's think about it. Let's do the algorithm here. So that would obviously become 4 over 1. And then we know that division is just multiplication by the divisor's reciprocal. So it's going to become 4 over 1 times 6 over 1, which gives us 24 over 1, which equals what we said. Okay? This is exactly why division is just multiplication by the divisor's reciprocal. Okay? Let's go on to the next page. All right, got a few questions here we're going to do. Okay. If 30 gallons of water are poured into 1/5 gallon containers, how many full containers can be filled? Okay, again, ask yourself, whole divided by part, equals part. What's the whole? What's the total amount? What's being divided? Hopefully you're all seeing it. Well, it's got to be 30. And I'm dividing it by 1/5. So we do our algorithm. Okay, that's going to become 30 over 1 times 5 over 1, which is going to give me 150 over 1, which equals 150. Right? It's just 30 times 5 is really what you're doing. Because you know that each gallon is like a bottle of water. It's like 1/5. So it'll take 5 of these containers will just be 1 gallon. So obviously 5 times 30. But again, you got to think of it in terms of division. What's being divided? Well, that's what's being divided up. This is just the size of each group. 1/5 gallon containers. Let's do the next one. Okay. In January, Jane volunteered at a hospital for a total of 12 hours. She spent 4/5 of an hour at the hospital every time she volunteered. How many times did Jane volunteer in January? Again, right back to this, guys. Right back to this. You're going to hear me say it all the time. What's being divided up? Is she dividing up the 4/5 hours into little groups, smaller groups, or is she dividing up her total of 12 hours? Hopefully you're all saying she's dividing that by 4/5. That's the whole. The part is just how long she's spending every time she volunteers. So then we do the algorithm. Dividend stays the same. Divide becomes multiply. The reciprocal of 4/5 is 5/4. Now at this point, remember, we can use cross-simplifying. 1 and 5 doesn't help me. I know that 12 and 4, they share a 4. So I'm going to do divide by 4 there, divide by 4 there. We're going to get 15 over 1, which we know means 15. So she spent 12 hours. She spent 12 hours volunteering. Each time she was there, she spent less than an hour. So if she spent less than an hour, that means she's going to have to be there more than 12 times, right? That's why the number got bigger, because you're saying how many groups of 4/5 would go into 12, which means if this number is less than 1, this number is going to get bigger because she's spending less than an hour there. If this was 12 divided by 1, and we said she spent 1 hour each time she went, she would have gone 12 times, right? Makes sense? Okay. A recipe calls for 3/5 cup of flour. Courtney wants to cut the recipe in half. How much will she need? Well, if she wants to cut it in half, how much is she going to need? So on this one, you're going to take your dividend, which obviously is right here. This is what you're dividing up. And in this case, you're going to divide it by 2, right? Because think about it. You're dividing it by 2. You're not dividing it by 1/2. Okay, you're dividing it by 2. Then we're ready to do the algorithm. So we're going to do 3/5 times 1/2. Check for cross simplifying. Nothing there. We're going to get 3/10. So she only needs 3/10 for the recipe she's making. Okay? Okay, bring that back and get rid of that. Oop, I missed this part. Sorry. That's okay. I remember the answer was 3/10. Okay, now she wants to triple the original recipe. So now we're taking this. If she wants to triple it, then we need to take 3/5 and we need to multiply it by 3. No division at all, which is going to be 3/5 times 3 over 1, which is going to give us 9/5, or 1 4/5. Okay? Now, if you were going to use division, hopefully you're all seeing, well, couldn't you just do 3/5 divided by 1/3? Sure you could, because that is the reciprocal, so that would be turning to multiplication. That would be the reciprocal of 1/3. Okay? So Luke has 6 sheets of colored paper. He uses 4 sheets to make posters. He cuts the remaining paper into equal rectangles to make greeting cards. Each rectangle is 1/4 of a sheet of paper. How many greeting cards does Luke make? Now this question right here could pose a little bit of a problem for some of you, because there's a lot of information given to you, and a lot of it's very distracting. Okay, first thing, a lot of you might think, oh, well, it's 6 divided by 1/4, but it's not. Okay, you got to understand that Luke is starting with 6 sheets. He's using 4 of them. he used 4 of them for posters. So he made his 4 posters. Then it says he cuts, which you should all know is a very typical division word. He cuts the remaining paper into equal rectangles to make his greeting card. So it says right there what's being cut up. The dividend is always the number that's being cut up or being sectioned off or grouped up or being divided, is how I've been explaining it. So it's not that he's cutting up 6 sheets of paper. He's not cutting up 4 pieces. He's cutting up 6 minus 4. So he's taking those 2 remaining papers that he has, and he's dividing them into 1/4 size pieces. How many greeting cards is he going to make? 2. Well, that becomes 2 over 1. And then 2 over 1, division becomes multiplication. Sorry about that. Okay, so division becomes multiplication, and the reciprocal of 1/4 is 4 over 1. So we do top times top, bottom times bottom, we get 8 over 1. Now, I can give you a perfect example of why, when you start with a dividend, in this case of 2, how you ended up getting something larger. Well, let me explain. So we have 2 whole pieces. That's our whole, right? Because again, keep coming back to this, whole divided by part equals part, right? So if he's cutting each of those like this into 1/4 size slices, this 1/4 is representing the size of each group. So that means there's 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6 pieces, 7 pieces, 8 pieces of cards or pieces of paper to make his greeting cards. Okay, but obviously you have to show all this work and all that, so just keep that in mind. Oh, sorry. Let's go to the next page. We'll go to page 11 here. A couple more. Just 2 more here we got to do. Okay, a party-sized sub sandwich is prepared for a team dinner. The sandwich is 5.5 feet long and is divided into 1/2 foot pieces. Write this again because we got to think in terms of, I mean, it says the word divide right there, so I mean, you know it's a division question. So now it's all about identifying the whole and the part. So remember, the whole is always going to be the number that's being divided, being cut up, being sectioned or grouped. Okay? The divisor, the part, is always going to be the number that is doing the dividing. It could be the size of each piece or the amount of pieces. Okay? So in this case, I know that we're going to be doing 5 1/2 divided by 1/2. Now this is the first time on this one that we've done a mixed number. So let's remember, I want this done in 2 steps. 2 steps are going to happen. The first step, the only thing you're going to do is they're going to be put in a fraction form. So 1/2 is going to remain, but we've got to turn 5 1/2 into a fraction form. So we're going to have to put that in improper fraction. So remember, just a little refresher, when we're turning a mixed number into an improper, we got to go around the barn. That's when we take the amount of pieces, the total, the denominator, the amount of pieces that each hole's cut into, we multiply it by the 5 holes, that's 10, and then we're going to add on that 1. So we know that's going to be 11, and then the denominator does not change. Okay? And I wish I had given you guys a little more space here. I do apologize for that. We'll move number 2 over to here. Then step 2 is just doing that algorithm once again. So 11 over 2 times 2 over 1. Division is just multiplication by the divisor's reciprocal. So the reciprocal of 1/2 is that. Now we're going to look to cross simplify. 11 and 1, nothing there that would help me. 2 and 2 definitely share a factor of 2. So we can divide by 2 to both those. Now we're going to go ahead and do this. We're going to get 11 over 1, which we know equals 11. Okay? So that means if each piece is 1/2 foot long, I can get 11 pieces out of that. All right? We'll do this next one. This one is very similar to question on the test, so you might want to put a big star by this one, guys. There's a test question just like this one. 4 of my best friends are over at my house. I had 7/8 of a pizza left over from last night. I had 7/8 of a pizza. Should have just said 7/8 pizza. So 7/8 of it from last night. So that's how much we had left over. If I want to give my friends an equal amount of pizza, how much pizza will each friend get? Okay? So again, I see that I see 2 numbers up here. Now a lot of you are going to get into this really, really bad habit. So please hear this, of just simply always dividing the first number you see by the second number you see. That is not how this works. It's all about identifying this again, identifying the whole, identifying the part. okay? You've got to be able to identify those things. What is being divided? Am I dividing up my friends? I'm not dividing up my 4 friends. I'm not doing 4. If I was doing 4 divided by 7/8, that's me saying I'm taking my 4 friends, I'm dividing them into group size of 7/8 or 7/8 groups or whatever. Okay, that doesn't make any sense. That's not what's being divided. What's being divided is that pizza that I have left over, which is 7/8 of it. So we're going to take 7/8, we're going to divide it by 4. Okay? Now we're going to make that 4 over 1, obviously, right? I don't know where my dots went. Should have been there. Okay, now we're going to go ahead and do the algorithm. So 7/8 divide becomes multiply. The reciprocal of 4 over 1 is 1/4. We check for cross simplifying. 7 and 4. Nope, nothing there that they share. 8 and 1, they share a 1. That doesn't help us. So then we're going to go ahead and multiply top times top, bottom times bottom. That gives us 7 over 32. We need to make sure this is in simplest form. Okay, so in simplest form, then I know that the only factors of 7 here are 1 and 7. 7 is the only thing that could help me. 32 is not divisible by 7. That is in simplest form. Okay, so as I've said several times throughout the video, it's all about identifying the dividend, what's being divided. That's really the whole key to this. If you can identify that, you guys are pretty good about figuring out how to divide it. I don't think it's the algorithm that's the problem. That's not the issue. It's being able to identify what the dividend is and which one of the divisor is. Okay? See you guys.